Nutherius, hello. Quecko, hello. God, it's hot. Steak, hello. Connor, hello. I don't have the portable AC unit at the moment, so I'm just in the sweat locker at the moment. Julian, hello. What am I doing today? What are we doing? Who am I? Who are you? What's the plan? What's the project? It's only getting out warmer in the week here as well. Threads, yes, something threads. Right, I want to throw away our thread abstraction and rewrite the whole thing today. That's plan the first is to rewrite all of the thread abstraction. Plan the second is to then use that new abstraction, which will be entirely over Win32 primitives, to do more interesting, fun Win32 things. I've just realised, rats, I meant to save, I found an interesting link and I have forgotten to save it somewhere where I can get access to it because I will need it. Here we go, right. I'm not totally terrible at what I do, but most of the time. Right, save that off. Right, okay. So let's jump into it and let's start talking about all the issues. Right, let's generate some shorts. I mean, let's do some coding. So at the moment we have a thread abstraction. It has pretty much, it's a very similar interface to your regular thread. It has a name, which is for our own use, and then we have some callable and then some number of args, right? And then this just basically bungs it all into a jthread, okay? That's kind of okay, but the problem is that jthread is in and of itself an abstraction. It's a great abstraction. It's one abstraction you should use, but it is at the end of the day an abstraction. And if you want to go any kind of lower level, you kind of need to bust out of the safety net of the standard library. jthread does supply a native handle. Okay. The problem, one of the many problems I have with the unique build system that I do have, is that we're using MinGW and GCC, which I believe implements it in terms of pthreads, but the Win32 build for pthreads. So and this is the problem we had last time when we were trying to do this, because I went and looked at it afterwards. In our specific build, native handle does not return you a Win32 handle, it returns you a pthread handle. And I don't really know how to go from that to the Win32 handle, and if that's even possible. And also it's getting a little bit hairy at that point anyway, so I think we should stop. We should rewrite it in terms of just Win32 functions, which will give us access to all we want. And then we're kind of good to go then to do all the other fun Win32 stuff. The other issue is that we will need to wrap the main thread in a thread-like object, so we can also interact with that, because we're going to want to profile and interact with all the threads, not just the worker threads. So munging an existing thread into this is also very difficult, but if we rewrite it in terms of like Win32 primitives, we can just get the handle for the main thread and shove it in there. It's not complex for no reason. It's complex for a very good. There's an excellent reason for this. So yeah, I think unless you're saying the current system is complex for no reason, or you're saying that my explanation is complex. Owen, hello. Emery, thank you very much. Still here after 20 months. Exciting. Right. Let's start writing some code and see what goes on, because also, like, you have to remember, like, this is probably the only real side quest I plan on going on as part of this project, right? Because I really want to just focus on like the rendering and then the physics and then the animation and the gameplay. Doing custom profiling stuff is a bit of a side quest. However, like, there's kind of two outputs for this project, right? One is some sort of vertical slice of an FPS with all the bits I want in it, and the other is like as educational material. People come along, we do interesting stuff, people ask questions, I help out. Hopefully people learn something. And there's a lot of interesting stuff. Like we're going to go through some fun C++23 shenanigans today. So I think there's value in this. So basically, at the moment, our current implementation has a JThread, right? JThread being a joinable thread. So the idea that being the original C++11 std thread. If this thread object goes out of scope, i.e. the destructor is called and you've not joined it, it will call std terminate, which everyone thought was a good idea at the time, and then afterwards everyone thought it was a terrible idea. JThread is the retroactive fix, I guess, but you can't fix it. You have to implement a new type, which means joinable thread, and it just means that the destructor will call join for you. So the destructor of JThread blocks until the thread is completed. Yeah, I mean, threads aren't too bad, right? It's the threads themselves are not too complex, right? It's the implication of threads that's complex. It's the data races, it's the deadlocks, it's the non-determinism. That is where it gets complex. Actually, building a thread to run it is not too bad. No one's implemented std hive yet, so I can't use it. But as soon as GCC has it, we'll give it a go. I sound a bit ill. No, man, I'm just really warm. It's bloody hot where I am. Right, let's, I guess, just start chucking some of this stuff away. We're gonna have to think about what our unique ID is going to be. I just think it has to be unique, so probably just like a static counter. Right, let's get rid of. We're gonna have to think about exceptions as well, right? For how we're going to bundle all this in. But I think we can just let's go back down to the. Let's keep that as that, and then we're gonna keep this. Get rid of this. Okay. So we're still going to need a stop token, but we're probably going to have to manually create that. So let's get rid of that for now. Get rid of this. I suspect most of the stream today will be building this out because there's a lot of oddities around it, but we'll do as much as we can and see if we can get to profiling. Also, as some people have already pointed out, the UK government has kindly given me a day off work on Monday, it being a public holiday, so we can maybe stream a little bit later if I don't collapse. That's fine, that's fine. So we're going to get rid of this. So far we've kind of just like stripped everything out. I suppose that could just be ID. Okay, so we've already got the windows included. Yeah, that's true, yeah. Oh, right, okay. So what we're going to be using is a function called create thread. Okay, this is pretty much does what it says on the tin, right? Creates a thread to execute within the virtual address space of the calling process. Bish bash bosh, right? To create a thread that runs in the virtual space of another process, create remote thread, so you can, Windows will let you create a thread in someone else's process, but we don't need to do that. There's a bunch of gubbins we have to pass in, stack size, start address, blah, 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 blah. But basically the two boilerplate, the two interesting ones for us are the start address, i.e. the address of the function you would like the thread to start executing, and the parameter. So create thread in Windows land will only let you, technically, will only let you start a function which takes a single void star parameter, right? Which is not, it's not great when you have an arbitrary number of real parameters. So we're going to have to reify that, right? So there's going to be some trampolining, there's going to be some packing stuff into tuples, there's going to be a whole, that's the first thing to try and cover, right? Well, if lifetimes in terms of these types, so the whole point, we'll get into this, but the whole point is that your standard thread and JThread only take copies of stuff into the new thread, right? So we have to use some decaying and some magic to basically make sure we don't have any carry over any references or anything like that. Kind of gets a bit confused with some of the C++26 stuff. Like here, like it says here, under reflection, but it's not so bad that I can't use it, right? Okay, so what does create thread return us? Let's just go through the docs. So security attributes, blah, blah, blah. I think this can be null. Stack size, the initial stack size, blah, 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 blah. We can enter 0, keep it at start address, parameter, creation flags. So you can create it in a suspended state, which we won't. And then thread a pointer variable that receives the thread identifier. The thread identifier is not returns. I don't know if we need the thread ID because I think we only really care about the handle. Because you have to remember, right? So Clang doesn't have that much C++26 support yet. So whilst your compiler like GCC will understand it, ClangD, which will be just using LLVM and Clang under the hood, will only be able to go up to the features that it has knowledge of. And then return value. If the function succeeds, the return value is a handle to the new thread. So this is what we want, right? We want this big angry Windows handle, okay? So we should be able to do something like handle, right, thread, right? Handle. Probably not like that. Ugh. Okay. And then we can do this to handle. What did it say? Is it invalid handle or is it null? Because it says return null. So let's do null. Okay, so there's kind of, I guess, two questions here. Like one is how do we pack the, sorry, one question. How do we pack all this into a void pointer? Oh, no, sorry, there's two questions. How do we pack all this into a void pointer? And then how do we get this to get launched via a function that just takes a void pointer? Yes, invalid handle is, I think, -1. I think you're right. But I'm just going by what the docs say it returns. If it says it returns null, then I would consider that the invalid value. We should probably use auto, actually, thinking about it. We should probably use auto release, right? Because I might as well have this automatically clean itself up at the am I gonna have to join on this? We might need to have our own custom destructor. Yes, okay, fine. Actually, I'm not going to use that. We will have a thread here which will do the cleanup for us. Well, you have to remember, like, you only want to pass this in, right? Because that's the thread object. You have to have access to this f, which is some callable, right? So let's go through it's pretty easy to go through the docs, right? So this is basically what we've got, right? This is C++20, the third one. We don't have to worry about all the others, right? But this is the constructor that we care about. Creates a new thread object and associates it with a thread of execution. So under the hood, this will use create thread on Win32, right? The new thread of execution starts executing. Stood invoke decay-copy forward. Don't worry about stop taking a moment, but basically it's going to decay-copy forward f and decay-copy forward args. Now, decay-copy is really important. This here is basically it automatically wraps it returns a copy of the object decayed, and decayed means remove const, remove ref, turn arrays into pointers and function addresses into function pointers, right? Has it got a link to decay in here? But this is this kind of like, occasionally you see this in the standard, right? This is this exposition, right? It's basically saying that this thing is quite complex and we only want to write it once. So we'll create this nebulous thing called decay copy and give it a bunch of rules. And then whenever we use that term, we mean this. So you see here, it says exposition only, right? It effectively does a copy. It takes in a PR value, right? And then it produces another PR value, which when materialized will result in a copy of this value decayed. So just for ease of purpose, just imagine that what actually happens according to the standard under the hood, right, is we call f, right? with the arguments we passed in, but those arguments get decayed, which means they get copied. So this is the bit of the word that guarantees that your new thread gets a copy of the arguments you passed in, right? But there's some fun C++23 isms here that I think we can make advantage of. So the first thing, right, we need to do is we need to package everything up into a... We're gonna have to dynamically allocate something, right? That's basically the only way to do it, because we have to get a void pointer to something, and that has to persist till at least the thread has started, right? So you don't really want to be messing around with stack allocated stuff, because you need that thread to take ownership of that pointer. So you have no choice but to stack allocate something. So what is a good way of bundling loads of things up together? Probably wang it all in a tuple, right? And then stick that on the heap. So effectively what we're going to do is we're going to want something like... This isn't real syntax, but I'm just trying to illustrate it roughly. Also, to help me process this as well, because it's been quite some time since I've done any of this. Basically what we want is this, right? We're going to want somewhere something like this, okay? Right? And then we can pass that in. So I'm also going to need some sort of private auto trampoline void star void, right? So this is going to be the thing that we call, right? So because this as a static function, this will satisfy the calling convention required by create thread. So we need to bundle everything up, stick it in this, and pass it on. But make sure we do the decay and the decay copy on the way. We want to stick into the tuple a decayed copy of all the arguments. Maybe not a lot of ranges today, no. So let's try this, right? So I don't think you can use make unique for this, because make unique requires you knowing the type a priori, and without doing a bunch of, like, I don't know, template misery, it's possible to know what the type of the tuple is from these. You might be able to write something to deduce it, but it's probably easier just to let the unique pointer, sorry, the tuple, the ctad on the new tuple figure it out for you, right? Right? Because then what we can do is we can immediately do auto thread data point equals stood unique pointer, some like stood remove pointer t thread data. Might need a type name in there, because what we want to make sure we're type safe as well, right? Like, we want to make sure that we don't leak anything. So this, if we I might need decal type in there. So basically, well, I don't think make unique will make you... No, because we don't want to allocate, right? This is the whole point. This does the allocation. This takes ownership of the pointer, right? And I don't think we could make unique without somehow constructing this a priori. And you'll see in a minute, like, I don't think it's going to be possible. So this might be one of the few cases where we do new and then stick it straight in unique pointer. But it's fine, because as long as nothing throws between this line and this line, which it can't, we're safe. So now if anything happens after this, we're all safe, okay? So I guess the question is, like, what's all this gonna look like? So I think we can just start sticking arguments in, and I think it will something ctad will figure out for us. So let's go have a look here. Right. So we want to decay copy, right, forward F, and decay copy forward args, right? So I think what we want to do is basically something like this. So you could do stood decay t f something like that. Probably means to be stood forward f. But that would just create the type, right? So actually you want to create the type f and then copy it. So you need to then use this. So you actually probably need to use names. Anyway, it all gets pretty messy, right? But C++23 introduced a new decay copy keyword, which is just to use auto, right? So if you just stood forward f, right? By wrapping it in auto, this guarantees that you get a decayed copy. And in fact, if you go to the decay copy page, you can see here, I'm sure it's in here somewhere, the language feature AutoX introduced in C++23 also allows decayed copies to be created as PR values. The only difference is that a decayed copy always materializes value and produces a copy, while AutoXpr is a no-op if Expr is PR value. This is technically more performant or more efficient than doing it the old way, which is probably something like this, right? Or this misery. Because doing it the older way, right, with all the decays and everything, will always cause a copy to happen. But this is clever enough such that if this is already a PR value, right, then it will just be a no-op and it'll just pass it straight through and then you'll get a copy of it. And then it'll automatically get a copy of it when it calls the tuple constructor. So you don't end up with like an extra copy. Anyway, it all sounds good to me. So we should be able to do something like this, right? So this should, in theory, generate for us a tuple on the heap, right? Or with dynamic lifetime, whichever you want to say it, with a automatically decayed copy, okay, of the function and the args, okay? Do we think that this has a chance of working? Can you make unique if you make it a base class? Yeah, but I don't really want to be fuffing around with like anything more complex. Like this is already complex, right? This is already quite on the sort of skirting around the edges of the language a little bit, right? As in like this is already pretty weird. I don't really want to make it any more complex. Okay, God, it's hot. Sorry, excuse me. Oh, sweat storm. Okay, that all sounds great to me. What are we doing right now? I'm trying to decay copy a variable number of arguments and an invocable into a tuple on the heap so that I can then pass that into a new thread via Trampoline using the Win32 API so I can get the handle, so I can do the bit that I actually want to do. I still do not see destruction. Like when this goes out of scope, it will destruct, right? And then it will clean up the memory. Okay, so now what we can do is we can do something like handle equals create thread. Let's try this. Null pointer 0ZU trampoline. And then right thread data pointer dot get, right, and then what are the other arguments I don't care about? I think it was the flags. This is just the flags then, isn't it? Which are then 0. Run immediately. So this will start up a thread, okay? Boost will probably do something like this, but you'll see that the kind of stuff that I want to do is probably not in Boost. And also, again, it's kind of fun and it's good, hopefully educational. I'm not saying you should always do this, but sometimes it's fun. Sometimes it's fun just to go on little side quests. The thread will get deleted object then. Thread will get deleted object then. I don't know if you hit enter too soon because I feel like there's a second part of that sentence missing. Okay, so now we're in an interesting point, right? So we've passed this in, right? Let's forget about this. Forget about this for a minute, right? Yeah, well, I'm getting there. I'm getting there. Okay. What's going to happen is that if handle, right, does not equal null, right, which is what it says it returns, right? Actually, let's do the other worst case. If that equals null, right, then we can throw exception failed to create thread name, right? We're having a bad time. Have I not got my custom exception class in here? I do not. How bad of me. Hash include utils exception. Right. Okay. So now the thread failed to start, right? So you can infer from this that this function never ran, okay? And that's fine. Which means this is still in scope, which means this still has valid. We throw, stack unwinding happens, this clears it up, right? Else, we get to the bottom, right? And then we do thread data.release, right? Because this now means if it did run, okay, that means this function ran. That means we can assume ownership within that, which we've not done yet, but we can, which means outside of here, we don't care about anymore and we can release it. So we're going to kind of pass the owner. It's a little bit grim, but we're going to pass ownership of the unique pointer across a thread barrier. Okay. And then in here, we can do like wait for handle and all that sort of stuff. Can you guarantee the function right away? Yes, you can guarantee that if you get a handle back to the thread, then the thread is now running, okay? And as long as we, I guess what maybe the point you're alluding to is there technically a race condition between like here and there, and it'll be fine. Hello to Brazil. Strictly speaking, a bunch of bad stuff may happen in between successful create thread and trampoline, but like what? Like what could happen such that create thread doesn't immediately return error, right? If create thread has returned you a handle, then the thread must be running, right? Which means your code must be executing, right? We obviously have to be careful what we do here, right? Sorry, here. So what we need to do is we now need to cast this back, right? Thread might not start immediately, but it doesn't matter. It doesn't matter how long it takes to start, right? Because we're done with it here, right? We know the thread is going to run. So release, it doesn't call the destructor, right? Release just says, I'm done. Unique pointer like just drops it on the floor and walks away. You have to remember this does not call the destructor of the thing inside of it. This basically says, I am released of my responsibility to destroy this. Okay, so as long as this starts at some point and executes, then it will pick up that memory. Like, I'm sure there is some horrific edge case within the Windows kernel that I'm unaware of, but like by and large, yes. Well, I won't need close handle if it fails, right? And I'll do that in the destructor when I get to it. So yes, there's a lot of stuff missing because I can only write one bit at a time, but we'll get there. So now, we're so close to getting there. We're so close to getting there. So now we need to recover this over here, right? So we need to return it back. So we're going to need some sort of template, right? So then what we're going to do is we're going to do auto. What do they call it? Thread data pointer. Auto thread data pointer equals static cast t star data, right? And then auto thread data equals stood unique pointer t thread data pointer, right? That's what we're going to end up doing. Okay, let me just get rid of some of this, right? So we can kind of see these byte next to each other. Still can't quite see next to each other, annoying, but basically, I've got this the wrong way around. I've called the unique pointer that thread data, sure, and then pointer, sure. I don't really like either of those, but sure. Right, okay. So the idea being, right, is that this should be relatively safe in terms of if we throw or exit early, right? Because anything after line 30, right, from line 30 onwards until we do something weird with it, RAI, right? If anything happens, if we early exit or we throw an exception, then we will clean up this new, right? This new is safe, okay? So at this point we throw, this gets cleaned up. Obviously, when we get to line 38, we release it, so we abstain, we absolve our responsibility from it, okay? So obviously we can't use this afterwards, and we no longer have RAI. So this, you could basically say at this point, right, this memory is leaked. However, what we do is if we reconstruct this, right, and stick it in the unique pointer, we have that RAI back. So now anything that happens within Trampoline, okay, whatever happens, if that goes out of scope, then that memory gets reclaimed. No, I thought release. Oh, is it? Have I used? Have I naughty me? Have I used the wrong function? That's the thread. Oh, sorry. Look at you. Stood unique pointer. Returns a pointer to the manager object and releases the ownership, right? The caller is responsible for cleaning up the object, okay? So release just gives you back the pointer, right? And says, I'm done with this. You clean up, mate. Your job. So we reconstruct that across the thread boundary and we stick it back into another unique pointer, right? So obviously, the issue is if this passes, right, and it never gets to here, then sure, it will leak. But I can't really see a massive situation where that's going to happen. Like, I'm not saying I'm a Windows expert, right? And I don't know the intricate details of kernel 32, but like this is pretty much the expected path of thread, right? It'll either run your code or it will not. And I'm pretty sure this is how std thread works under the hood anyway, or something similar. Yeah, so I won't be like, this will get freed automatically when it goes out of scope, okay? Exactly, yeah, right, exactly. Okay, so now that we've got this templated type, so I think what we're going to have to do is we're going to have to, using tuple type equals std remove pointer t decal type thread data. All right, and then this can become tuple type. And then this can be tuple type. Yes, no, I mean, do question me because I could get it wrong, but I'm pretty sure this is the right flow, right? Stuffing args in a member of thread, and the benefit is only slightly shorter. Is it better than that? But you're still gonna have to do the decay copying, right? Because no, because how would you know what the members are, right? If I cannot store args as member variables unless this becomes a template of thread, which I don't want, right? Because in that mean it influences the type. And then I still need a static function, right? I still need a free function or a static function to pass to the trampoline because I cannot have an implicit this pointer as the first argument, right? unless you took that as the first argument and then reconstructed the object and then pulled it out. Maybe. I don't know. There's multiple ways of doing this, right? So you're saying that you would then basically have this as like thread this, right? And pass that in and then reconstruct it. Sure, like, I don't know. We've got this now, and I don't think it's a lot of extra typing. I don't really think it gets you either way. I'm trying to think if there's a reason to not do it. I mean, there's multiple ways of doing everything, right? Dealer's choice. The trampoline is so that I can fit the shape of the Win32 API. The thread object outlives the thread if you do it right. Yes, it'll have to, because I think I'll make that part of my kind of design. Hello. Sure. Dealer's choice. I don't think it's that bad. So then we can reconstruct this. And then we have the fun of now we have to pull out f and pass in the arguments. So basically we will need, I'll try and get this right now. Just find this quickly. Still apply, right? So this takes a function f and a tuple, and it invokes the callable f with the elements of t as arguments. So automatically unpacks the tuple and passes them in as each argument, which sounds kind of like what we want. But we have to remember that actually our tuple will look something like f and then args, right? So that's what's inside our tuple. So we need to kind of be careful about how we invoke this. And also we don't want to, if someone passes in a tuple as an argument, we don't want to actually unpack that. We have to forward that on as a tuple. Shared pointer is really just not what we want, right? It doesn't get us absolutely anything. There is no shared ownership here. That we still maintain unique ownership. So if we do std apply, right, over some function, and then the tuple can be, I guess, thread data pointer, but we can std move that in. I don't know if we then need to release the pointer afterwards. Is that going to work for us? Don't think we even need the move, because I think we're going to take, this is going to take another copy. I think it might, but I think it's fine because it's going to be a slow operation creating a thread anyway. But anyway, what I'm saying is you have to remember that this type here is a pointer to the original tuple that we constructed, which has the first argument as the function, and then the remaining arguments as the arguments that we want to forward onto that function, right? So we have to first unpack that and then invoke it on it. So if we do, you're going to use a stateless lambda to unpack it. Yes, basically that's what I'm going to do. I'm going to basically say, so if I do class f, right, class args, right, and then do ff args, right. This will invoke, right? This will apply. Sorry, so this will basically call this function with the unpacked arguments, but then I can use templates to basically pattern match on those and get access to the individual ones, right? Which means I can then do something like, oh, hang on. Stood invoke, right? Stood forward F, F, stood forward args, args. I think I want something like that. Where's stood invoke? Utilities? Functional. Oh, is it just because I spelled forward wrong? You can have the function tuple of args as a member. Yes, we've already discussed that. Like, this is just another way of doing it. This is just the first way I thought of doing it. Doesn't mean there are not other ways. Doesn't mean that you could not do it a different way, but this is just the way that I've chosen to do it. So this should, in theory, do everything that we want, right? So it should, I was saying there's a bit of C++ intricacies to this, but this should unpack that tuple to get the function and the args out, and then it should invoke those args on that. And we're using stood forward because we have forwarding references, so it means all the value categories just shuffle along nicely, or at least it creates the right reference type based on the value category of the thing you passed in, blah, 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 blah. And then I think that's pretty much it. Have I ever attempted multi-stream plugins in OBS? Yeah, I'm multi-streaming now, mate. Like, we're doing it right here, right now. We're going to Twitch and to YouTube. Yeah, we could potentially do that. I'm not as, like, I know I said like this is more efficient using auto decay copy here. Like, this is the setup for creating a thread, which is going to be hugely expensive anyway. But yeah, I mean, obviously we should always be aware of the performance, but we're not going to be creating like threads in a busy loop, right? But yeah, it might be something to play around with. I'm not that fussed about doing it now. Yeah, this is basically type erasure, right? This is basically how like stood any and all that kind of stuff works. Is you boil everything down to a void pointer, and then you use a templated function which effectively remembers the original type for you as part of like the type system, and then as part of whatever it actually gets compiled, and you use that to recover it. I am thinking we might need to, I might need to go back on what I've said and store this as the member variable anyway, because we're going to need access to this for handling exceptions. So I might need to go back on what I said anyway and do that. But let's see where we go. The only problem with doing that is that I can't have a unique pointer as a member variable, right? Because how would I know what type is stored in it? Because I won't know it until this, right? So the class itself cannot know based on these constructor types. So I'd probably have to store the void pointer and then recover it. So I might end up just shoving in a reference to what I want in here. Right, because the people are saying store it as a unique pointer here. Like, what would that type like? So I'm curious now, because I think this is interesting now. Like, what would T be here? And I don't want to template to thread because I'm trying to be similar as possible to the standard library one, because that's what everyone kind of knows, and I mean, no one loves it. I think it's great. Right, well, let's write this, because I've got to remember how this works now. So what we're going to do is we're going to basically say if, wait a minute, I think the invariant of this class is the thread is always run, right? And we don't provide any way of stopping it. So we don't provide any way of joining it early. So I think I can just do wait for single object handle wait. Is it infinite? I can't remember what it is. some Win32 rune that you draw in the sand to basically say just keep waiting till it's done. I should know this. Like I should know this. Is it just infinite? It's just infinite. Okay. And then this will basically, so this wait for single object. So this is effectively how you do join in Win32 land. You basically say wait for this single object to be done. Sorry, I did open it up and looked. And then we can do destroy thread, remove thread, delete thread. Oh no, it'd be close handle, won't it? Close handle. Okay, so that's our tidy up there. I think that's like, obviously this is not going to all pass all our tests because we don't have the ability to like, this isn't a great function. So we're going to have to create a stop token and pass that in, but we're going to have to make sure that gets passed. Oh no, you can copy, stop tokens are copyable, aren't they? So that's fine. So let's just see if this blends. And need ID too, yeah. I think I can just like create my own thread IDs, right? It doesn't really matter what they are. Blah. Blah, 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 blah. Okay. This is fine. We can deal with this. Well, I think just use stop token, right? There's no reason I can't use that from the standard. So I've already conceded there's an issue here with stop token. I think because I require stop token to be the first argument, so I guess it probably doesn't match. Let's have a think about this. So let's do std stop token. Stop token. And then that will just default construct it. And then I think I want if I pass that in there, right, and then request stop token dot stop requested? No. How do I signal stop token? Or can I not? It does say you don't normally construct it yourself. That is a little bit annoying. I might have to use... No, sorry, let me bring it up so we can share the misery together. It doesn't seem to... Can you not signal it? Is it really just an implementation detail? Yeah, I mean, we can just use an event, right? We could use a Win32 event, or we could use a condition variable. That's really annoying. Oh, you are right. That is going to be a massive pain. Well, you don't force stop, you request a stop, right? And then this is literally what JThread does, right? JThread allows you to construct with a stop token. Right, it's literally part of it. And like JThread holds private members to stop source. To stop source. Oh, here we go. This is what I want. This is what I want. Here you go. Stop source. Request stop. Makes a stop request to the associated stop state, if any. So this... So I get the token from this, which is the copyable type. Yes, yes, yes. Yes. So we go stop source. Stop source. Yes. And then this become source, and let's just check the constructors. It has a default constructor stop source with a new stop state. So this becomes source dot get token. I really hope this splits out some new lines soon. Sure. Okay. So this then becomes stop source dot request stop. Right now we're cooking. Yes. So I guess stop token is the copyable. I think it's reference counted anyway, but like I think it's the thing that you kind of throw around and interact with, and the source is what you actually trigger it through. Which, as I've not done this kind of thread construction specifically before with a stop token stop source, is probably why I missed it. That, and I just generally don't. I'm just making this up as I go along. Okay. This is the issue now. This is where it's going to get a little bit hairy. Okay, and this is where I clearly didn't plan ahead. Is if I require, so you can see here, right? This is my lambda here that I'm wanting to construct a thread with, and I've said the first argument is a stop token, right? I'm now gonna try and forward the args, which is this, but I've already explicitly provided it here. So the issue now is that if the lambda has the stop token here, then I've explicitly provided it. Oh, am I going to have to pop off the first args? Because I handle that manually. I'm happy to expect that someone always requests the stop token, and I think that's kind of fine as part of the interface. The problem is now is that this args is going to include it. That's fine, because what we can do is we can just do namespace. Nope. Oh, I'm in a header file, aren't I? This probably could be in a CPP file now. I can't remember why I did it header only to start with anyway, but it's fine. We're here now. Let's do template args. Sorry. Struct pop first type, and we'll provide a specialization, which is going to be template class head class tail struct pop first type head tail dot 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 or dot 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 tail. I think it's tail dot dot dot, and this will have using type equals tail dot dot dot. Hang on, wait a minute. I'll get there in a minute. I can't just expand that, but I need to return a type. I could use a type list, but how would I then get the types out? Rats. Because I need to be able to get the type minus the first one, but I want it as a type list. Pack indenting won't work because I want to slice off, right? What am I trying to do? I want to use auto, create that of a stood forward args. I need to slice off the first type. Overload constructor with token and tokenless arg list. Ooh, that might actually be easier. Yes. I'm probably, like most things in life, I'm probably overcomplicating this. So if we do studs. So you mean something like that? No, is that going to work? Tokenless arg list. No, because I don't want someone to pass in the stop token. I want a function that matches it, right? Yeah, but I can get a type list, right? And I can shove them all in the type list, and then I can pop the first one off. That's fine. But then how do I... It must be possible because the standard does it, and the standard allows you to both provide and not provide one. So there must be some sort of conditional based on that. I'm just trying to work out how... But I can't plug it into the whole tuple, right? Because I'm deducing this whole type here, right? Interesting. Okay, fine. I need to work this through. Okay, fine. Let's work this through. So we've got, I really wish this could be on some new lines, but I don't think Clang format is gonna help me here. No, thanks, mate. Okay, so we've got the function, and then I need to put in a, so I might have an XY problem, right? Which is perfectly possible, but I'm gonna accept some number of args. If the first argument is the stop token, then I need to provide my own and forward the rest of them, right? And I'm happy for that to be the only case, right? So we don't have to worry about the case where we don't provide it. Yeah, we can, but then like the question is like, then what do you do with the rest of the arguments? Because I'll only ever have them as a parameter pack, and the question is then how do I need to get a type here, right? Which is, I think I was onto something here, right? Can I go back? This is quite close to working, this. But I just need to access args. Basically, I need to change args here to wait a minute, hang on, whoa. What are you passing? No, hang on, wait a minute. I think I'm being stupid here. These are the arguments that they are explicitly passing me to forward into the function, right? So all I need to do is just... because they're never going to... Wait a minute, hang on, no. I must be being stupid here. Why is this not working at all anyway? Hang on, whoa. Let me go back to what I had, right? Because no one's... I think I might have just gotten the wrong end of the stick here, because no one's ever going to pass me a stop token, right? Let me have a look at where this actually fails. I think I might just be being stupid. Yeah, look, they don't pass me a stop token. They pass me a name and then a function. Hang on. Whoa. Don't I want to unpack around the auto so I get an auto copy of each one, like a decayed copy of each thing? All right. Wow, that looks. Is that better, or is that worse? Okay, we're back to this, right? Okay, fine. Ignore everything I just said for the last 10 minutes. I think it was absolute bullshit. I think the whole thing is a red herring. I think I just fundamentally don't know what I'm talking about. So it doesn't like this. Do I need to take the address of that? It definitely doesn't like this now. You can see every point it's failing to. No matching converting constructor from trampoline to type AK long. Oh, because it has to return a value. Okay, a long unsigned int. A long unsigned int. Is that like std size t? All right, let me have a look at this. I'm guessing now. Pointed to there you go. Pointed to the application function. The pointer represents starting point to C thread proc. A D word. The return value indicates the success or failure of this function. The return value should never be set to still active 259. Do not declare this callback function with a void return type and cast the pointer to the. Do not declare this as a void type and return it when creating a thread. Code that does this is common, but it can crash on Windows 64. Okay, so I was doing that wrong. So I need to return a D word. And what's the return value? Indicates the success or failure. So I'm going to assume 0 is success. We could actually probably be a little bit Windows specific there. D-word is the Windows type. Too few arguments to function create thread. Too few arguments. So I should have a security attributes null pointer, a size t, a thread start, the data. Oh, and then yes, I need another null pointer at the end, don't I? Of course I do. Of course I do. Absolute fool of a took. I mean, build linked. Well, it's built. I mean, the tests crash. We're basically done. No, I'm throwing the JThread stuff away and just using the Win32 API. Terminate after throwing an instance. It doesn't. I tell you what, it won't like me throwing because I need to stuff in exception, right? So this is fine. This is fine because what we can do is we can do. Also, am I passing in? I think I can peel off these, right? So can I do class S and have. In fact, actually, let's be specific. I don't need a template type here. Can I? Can I explicitly capture the stop token here? All right, because this is just part of me experimenting for how I'm going to get the reference, the exception pointer in there. Will that work? I really hope I can. I think that's how things work. I don't need what. So what I can now do is basically what I should be able to do is just start shoving more and more like crap in here. So let's do stood. I could just do it. Could just do it as a pointer. I could just do stood address of exception. Right. So that now means I'm passing in some more stuff I do, and then here I can then do stood. I mean, it's kind of like a double pointer at this point, but like, what are you going to do? And then we can do try catch ... Ooh, study one there. Exception equals stood current exception, right? I've obviously introduced a new short hotkey somewhere by accident, which massively collapses the code, and I keep accidentally typing. Then why does? Could you not? Like, every time I save it, could you not just cut? Well, I hate that. I don't know why it thinks that's necessary. Every time I save it, it goes, you obviously don't need to see this. Okay, fine. That was strange. And then I guess we could have auto ret val equals dword like that, and then we could do ret val and that reference, do ret val equals 1. Did you mean ret? I did mean ret value. You know what? I did mean ret value, compiler. How do we feel about that? I find code folding useful streaming because we obviously, like, I choose to have quite a large font size. I don't normally program with font size this big, by the way, and on a window this small, but for the benefit of all of you lovely people, I do embiggen the text size quite a bit, so I find folding it can be quite useful streaming, just to collapse like the noise down so we can just focus on the important bits. I wonder if this will work. I've goofed somewhere. Oh, because that's supposed to be a pointer, isn't it? And then this needs to be dereferenced like that. I mean, mate, your guess is as good as mine. The document doesn't say. It says return a value that indicates the success or failure of the function, and it says don't return 259. I mean, we have deadlocked. Okay, but like all the thread ones work, so we're definitely getting there. What has happened here? Is this non-deterministic? I suspect it being thread pool is probably something around it's kind of so. Again, I don't think this gubbins here, right, would be easy if we could pass in this and reconstruct it and store in member variables. I don't think we can do that with unique pointer, because I don't know if we cannot know the type a priori. So I think we're stuck with this. Stop token balks, almost certainly. Like it seems like a good guess. I mean, this is why you use the standard library, right? Because a lot of this is a pain, but I think it's fun still for now, and I think it's hopefully educational, and I still think it'll be useful for us. Okay, because it's a test, I am a little bit reliant on VS Code still for debugging. Let's run the tests and see if we can pause it and find out where the deadlock is. Do we need to test for stopped in the try catch? I don't know. Can I pause this and see what the threads are doing? So this thread is stuck in the... Ooh. Why is it stuck on wait for a single object? Why is that? This one's paused on pause. I don't know if you can see that, but that's useful. Don't we need to signal the thread to why have you got to be so sensible? Why have you got to point out all my mistakes? Yes, of course. I think we then do if stop source dot stop possible. Because I don't know what happens if you try and stop it more than once. I guess if you... I mean, that might not be the issue, but I mean, that is going to be an issue. Whether it is the issue remains to be seen. It got to the next test. Oh, you can't thread from a destructor. I don't think there's anything you can do about that. Okay, we're getting closer. It's definitely progressed to another test. Interesting. Right, I think we might have to think about this a little bit more logic. So what is that test doing? That is the thread pool test. Uh, 59. So sorry, thread pool. It's in thread pool. Sorry. So we get the starting worker thread, and then if the stop token is not so this is in the worker thread. So it's stuck somewhere in the worker thread. Interesting. Let's give this a spin and see what we get to. Okay, so we've got some threads. So this is still, why is it still waiting there? How's it ended up here? So it's gone thread pool. I think the issue is it doesn't have a move constructor, because you can see here it's actually, I don't know if you can see here, because partly because my big bloody dome's in the way and the font size is so small, but the deadlock, it's deadlocking because you've gone thread pool, right? And we've gone pushing it into this vector, and we've gone all the way through this vector gubbins, and then it's called the destructor. So the only way that a vector would destruct an object, right, outside of like it going out of scope or you clearing it, is if it's had to resize the vector, which almost certainly has done in this, in which case it's copying them, right? Because there's no, oh yes, right, fun C++, right, let's do this. Basically the issue is that by default vector will copy everything over, right, unless you have a no except move assignment, okay? or no except move constructor, both of them, either one, right? So if we look at thread, I bet this class is copyable, right? There's nothing in here that stops you copying it, right? None of these are inherently non-copyable types. So this is my fault, right? I should have seen this coming. Because the JThread isn't copyable, the class itself wasn't copyable. Absolute fool of a took. Right, so let's do thread const thread equals delete auto operator const thread equals delete. Okay, so this this might not compile. Oh, it might use the user generated move constructor. I can't remember. No, it won't. Yeah, look, it's going to fail now. Blah, 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 blah. User deleted function thread. Right. So now we need to make it movable, but we have to make sure that we do a proper move. Is there a macro to do? I pretty much am allergic to macros. I do not use them. There's only one place in this entire code base we use them, because there is currently not a C++ equivalent to get around it, to get the exact, to solve the exact problem I want to, and that would just type it out. Okay, so what we can do, I think we need a default constructor, right? This will make our lives a little bit easier. So this will, no name, no exception, stop source, and a handle, right? I'm wondering if I just use the auto release, if this will make our life easier. I just have this in the lambda that we pass in, because everything else can be moved. Do I sacrifice? Yeah, okay, fine. Take it all back. Let me reuse some code I've already written. Let's do util / auto release. So I built a primitive exactly for this. And I started using it at the beginning. I was like, no, I don't need it. But obviously I'm absolutely a fool and don't know what I'm doing. Oh, we've had this before where it doesn't like it being null. Don't have to do something like voids. How do we, where was, sorry, it's a bit of a side quest. Somewhere in file read? It might be forgiving. We'll see how we go with that. Don't need macros for reflection anymore, mate. C++26, reflection, done, solve problem. Okay, so let's do handle null, and then what we can do is, if we get here, then we can do handle equals auto release handle null, and then actually, can I just no, sorry, take it. Do handle and then auto handle. Oh no, because I need access to the stop source, don't I? So I won't get access to this. I think it's fine. I think we can cheat. Let me just pass in this there. Then we just do pass this up, pass this in there, and then might as well use the one I passed in because it'll just work. And then, all right, okay. Yes, good point. So this should be const auto new thread. If new thread equals that, and then new thread. I wonder if this will fix this for us. I can't remember how I munged null into that. I might have to just retreat it as a bad handle. Blah, blah. Auto release is basically unique pointer, but for non-pointer types. So like integral handles, right? That's basically what it's there for. Voiced. Why is it? I can use null pointer, I think. Yes, that's fine. Oh, have I already done this in Windows H? Okay, fine, thank you. Okay, fine. What am I missing? What have I done wrong? Okay, this is just a repeated error over and over again, so it doesn't like that, which is... Oh, have I got to construct it with a lambda? That's so annoying. Macros they're hard to debug, they're hard to reason about. It's kind of like auto-gen magic, which is kind of, I feel, just generally just hard to reason about. Do you know what I mean? Like, you can't set a breakpoint on it. I'd much rather use actual language features rather than, like, macros are basically just copy and paste, right? Okay, I should now be able to use the default ones for these two. Oh, it's looking good. Hour and a half in. Still writing a thread class. I think that crashed, but it certainly ran more. Do we need this many threads in the test? I might just so it's easier to reason about. What test is this? This is the thread pool CTOR. Can I specify the number of threads I want to work? I can. It's just splicing, mate. Just splice that reflective value back into the value space. Right. This crashes. Why do we crash? We're getting there. I can feel it. Segmentation fault. Stop source request source. Interesting. Has this gone out of... Is this from the moved from one? 0.6, yep. It was, well, it was agreed upon by WG21 at the Croydon meetup and has been sent, or in the process, been sent to ISO for official anointing with the requisite ISO holy water, and then it will be published as the next standard. But C++26 is done, it is complete. There is no more going in or out of it. So the thread pool's destructed, right? So it goes through all the threads and requests, they stop, right? And then it's gone through all these threads, and then it's gone to thread. the implicit description here, and then it's gone through auto release, right, which has an object and a deleter. That's fine. And a few more stack frames. Then we end up here. Is it because I'm capturing this? Oh, is it a destruction order issue? It'll destroy. No, that's fine because it'll destroy. It destroys them in reverse order, right? So the destructor for this will get called before stop source is destructed. The problem is, I struggle to use sanitizers in this setup because I'm using GCC with MinGW to cross-compile for Windows because that's a normal thing you should do. MinGW doesn't really support any of the sanitizer, so I'm kind of on my own for a little bit for this, which is a bit of a shame. It is a little bit annoying and has resulted in a bit of extra effort, but c'est la vie. Right, okay. Why is this? So this will get destructed first, and then this. So this is still in scope. What am I missing? MinGW. MinGW. I don't know. I'm not even being silly with that one. Mingua. What is the actual? I quite like the actual like address that it's circuit faulting on. Like, what's it failing to? The thread is requested stop. Then I don't think it is racy because. Because this blocks, right? Harand, hello. So this gets destructed. Well, I've not moved anything, right? The whole point is this should be, unless this is not movable. That's the only thing. Where's the docs for this? But it should just no, it's fine because it just calls the default move constructor will call stood move on everything internally, right? It's crashing before the block though, is it? It's finished. It's when it's cleaning up this vector, right? So it's when it's cleaning up workers, okay? Yeah, right. I get that. What have I what have I missed then? Like this. I've no idea if this is legit, but this looks like a. The so far was on. Yeah. So, but what? Because handle doesn't have anything at this point, and that's fine. Then we push in the new one. I just don't get why. Maybe double stop request. I don't know. Is stop like stop request idempotent? I doubt it. Request stop. Issues a stop request to a stop state. If the stop source object has a stop state and is not yet already stopped, issues a stop request to the stop state. If the stop source object has a stop state and it has not yet already had a stop. That's really hard to read that. And has not yet already had stop requested. The determination is made automatically, and if stop was requested, the stop state is automatically updated to avoid race conditions such that stop requested and stop possible can be concurrently invoked on the stop tokens of the. If the request stopped does issue a stop request, then any stop callbacks registered for the same associated stop will be invoked asynchronously. If the yeah, I think you can call this multiple times, but nothing in here is to say that you can't call it. I don't think sticking in a loop's going to help. Like, I can't even get it to run the first time, let alone multiple times. Yes, I mean, like, I've issued this here, right? So that's fine. So what does stop possible mean? Checks whether the associated stop state can be requested to stop. Yeah. So does it construct a stop? Yeah. So you get a stop source with the stop state with the default constructor. You have to say no stop state t to not have that, which I don't do any of that governs. Each thread should have its own stop token, right? So let me just it has its own stop source, and then from there we pass into the token, right? And then forward shuffle on the rest of the args with the decay copy. But we don't need to decay copy this because that will return a PR value, which will then. I don't think we need that. Let me just check. We won't need it for pointers. Points make. It's just ones and zeros. So object may have died between stop possible and request stop. I don't think so. No, it's still crashing. It's on the ending worker thing, which I think is interesting. So this might have to just put in a little bit of extra logging just to see if we can. I have used Valgrind, yeah. I don't think it's going to help us now, but I have used Valgrind before. Oh, Alex, well, thank you very much. Have a very kind of you. I can tell you now for free, my issue is not that I'm not using a linked list. Log debug thread. Sorry. Stopping thread. Static cast void star. Oh, can I access the this directly? Or is that going to give me the this of the lambda? Who's this is this? Who's this is this? Something weird's going on because I'm only getting this called once. Let's do having an aneurysm thinking about this issue. This is like just a mechanics issue, right? We'll figure this out when we'll get it done, and then we can get on to the interesting stuff. Okay, so thread starting. Why are they all the same address? Is it because why are they all the same address? Auto release move should be fine, right? It will just set the old value to be invalid, which will be null, and then internally in its destructor it checks if the null is there. I guess it's maybe it's going to construct them. I bet it's the problem. Is it a stack address? No. I was just wondering if it's constructing them in one place and then moving them. No, because it should. Pushback has a R value reference overload operator, so it should construct it in place. I don't know if that's just me being stupid or if that's something to be concerned about. Okay. And what we could do is we could avoid the need for this at all, right? So we could do stop token equals stop source dot get token, right? And then we don't need this, and then we can just do right. So that elides the need to worry about. Oh, I can't request the stop, can it? So it does have to be that. So we do have to pass in. Wait a minute, hang on. Whoa. Do we even need this? Can we do something like... Can this signal it? Because this will get called before all the members are destructed, right? So this will automatically get invoked, and then it will invoke this, and then we don't need to pass this in at all. I don't know if that makes it clearer. Yeah, it's probably almost certainly that. It's just strange to see, especially as I'm putting them in a vector. I'm so smart. Of course, I don't actually know what the issue was, which is actually quite annoying. It must have been a lifetime issue with that at this pointer. I really think it was the wrong way to do it anyway. But right, hang on, whoa, everyone, calm down. That was just one test of multi-threaded code. There's no guarantee it's going to work the second time. This is special. This doesn't get captured by value. You just capture this pointer, right? It would never copy the whole outer object inside of it. I think we're threading, gang. I think we are threading. Yeah, you just copy the pointer, but the pointer should still be valid because the outer member is still valid, and that's what you're destructing. I know, I always feel a little bit like irked if I don't fully understand it. I might spend some time trying to go through that. The other thing is maybe I was just missing this handle check. Maybe the handle wasn't valid anymore. Was I just drawing an empty one? Let's just... No, because it will still have to destruct the object, right? And the object will still have its destructor. When it resizes, it will still call the destructor on the old objects, right? And it will still first go the reverse order. I wonder if I just... Should I just had... If I make a change, then I won't be able to undo this. You know what? Actually, not going to look a gift horse in the mouth. Let's call it a day. Right. Great. Refactor thread to use Win32. That seems like a good commit. That is an hour and 45 minutes in, and we've done one commit. I think we should start doing the next bit because I'm happy to stream for a little bit later today. Right, so the next thing I want to do is I want to be able to produce... Right, here's the thing. Here's the end goal. I want to be able to profile a thread. I want to have a rough idea of the percentage of time that it takes executing the, like a breakdown of the percentage of time it spends in what code, right? So I should be able to see that it spends 50% of the time in this function, 25% of the time in this function, 5% of the time in this function, whatever the remainder is, because I can't do maths in my head, 20% time in this function, right? You should just use JThread, yes. Now, obviously, we can use the Visual Studio Profiler, we can use loads of other profilers, blah, 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 blah. But I think it's kind of fun to figure out how to do this ourselves. Also, I have maybe a slightly unique use case, is that I would quite like to, in main, so we've got like this macro architecture in main, right? We're going to pump the events. We're going to pump the Win32 events. We're then going to drain all of our event pool, all of our awaitables, and all of our queued jobs. We're then going to render, and then we're going to swap and go around. Okay, and then somewhere in here we can have physics as well. A profiler, like a sampling profiler, will just tell you like you spend 30%. Each thread spends 30% of its time in the physics update routine, and that's fine. But that also better example, it spends 60% of its time in the physics update routine. That's fine, because you might expect that to dominate it, but then that doesn't give me any information about like the percentage time it spends in the other parts of like this kind of top level architecture. So what I'd really like to be able to do is say, hey, give me a breakdown of the thread type of what the threads are doing in this block of code, and then in this block of code, and then in this block of code, and then we can be like, we might know that, and then maybe the overall arching thing as well. So we're like, okay, we know that it's spending the majority of its time doing physics, but like that doesn't mean we can't learn something about what it's spending. You know, there might be inefficiencies in other parts of the code which might still be worth addressing, because there's just a lot of physics it has to do. As an example, I want to also, like, it's kind of fun, right? Let's be real. Like, the part of this is just have fun. Like, I've allowed myself one side quest on this project so far. So what we need to do is to do a sampling profiler. We basically, for each thread that is running, you suspend it, right? So you tell Windows, hey, like, stop, like, just like, put the brakes on, stop executing that. You then capture its stack trace. So be like, hey, what the point I stopped you, what were you doing? You then save that off for later. And then you basically do that on, you basically jam the brakes off. You basically have thread ABS, right? You keep jamming it on and off really quick. And each time you generate a sample, right? And then statistically, you'll know that if there's a function that's called lots and lots and lots, statistically speaking, most of those samples, the stack traces for most of those samples will point to that offending function. So that's what we're going to try and do. Yeah, like, I don't really want to litter my code through too much with like random timing stuff. I want to go a bit deeper. Like, I want to have some. I want the game to be able to profile itself, right? The game can currently reason about its own memory usage. Like, it kind of knows what memory is being allocated and where. And again, we might be able to have like bounded ones. But the next one I think is, for a bit of fun, is this. Like, if it's a total disaster, then we'll just throw it away and I'll just use like the MSVC profiler, right? Or the VS one. But for now, like, I think this is kind of fun. So what we're going to do is we need the ability to suspend a thread, okay, which is easy now that we're using Windows, because it's literally just suspend thread handle, right? Job done, mate. Don't worry about it. Suspended, right? And then we need a way of getting the stack trace of that thread, right? And then we need a way of, and then something boilerplate machinery to kind of log it. Nah, mate, that's it. You get one shot. We can find out what it's doing at that very moment. There are a whole deluge of edge cases and issues with this, right? One that we can't use stood stack trace, right? And I'll tell you for why in a second. So we have to do it manually. And the other is that we have to be really careful when you suspend a thread, right? So and also this is another reason why I need to be able to wrap, because I want all this to be an interface, right? I literally want to be able to do something like auto current stack. Or just, I guess, just stack trace, right? Return something. Thanks, guys. I'm so glad you're here. So I want to be able to call from some profiling thread, right? So some profiling thread should have access to all the current threads and be able to call stack trace, push, something metrics, like stick them in a thing, right? So, sure. So we're going to do. Oh, fuck it. Let's just start writing it, right? I'll just show you all the issues that we're going to come across. All right. So I will type this in a minute. That is true, yes. So don't resume it. We'll just restart the program. Right. Okay. Get stack trace here. There's a couple of issues here, right? Because I think you wouldn't be forgiven for just be thinking, I'll just use like stack trace current, right? The issue with this is that I have to call it from the invoking the thread that is suspended, right? If I am another thread and I call stack trace, I will just get my own stack trace, which doesn't help me for the thread that I have suspended. Okay, so that is point the one, is that this is for the calling thread, not the this has no concept that it might ever be called from another thread, right? I've paused, some other thread is looking in and it said stop, and then it's like, where am I, right? Where it should be stop, where are you? The other issue is that this now, right, is the danger zone, right? Make all the arch references that you want, it's absolutely fine, I expect them all. You cannot reason in any way, shape, or form about what the thread was doing when you suspended it, okay? It is impossible to know a priori what it was doing. It could be holding a lock, okay? It could have just acquired a lock and then you're like, stop. That lock could be within malloc or some sort of memory allocator, okay? In which case, if I try to do any dynamic memory allocation in here, I could deadlock, because I could go to grab some sort of global, don't know, some sort of global mutex. Who knows what the fuck Windows is doing under the hood, right? All I know is that I have to be very careful what I do, that I don't do anything that could possibly assume I could grab some sort of lock. Okay, so we are like zero memory allocation, like. Also, right, so this is the other reason, hang on, whoa. Am I about to talk totally out my ass? Stack trace. Std stack trace, which is technically a basic stack trace, takes an allocator, which implies it does allocation. So you couldn't use std stack, even if there was std remote stack trace, you couldn't use it because it allocates. Yes, as of C++23, you can get the stack trace. We use it all over the place. We use it in our exception class. Oh, yes, off to a good start. How's the game coming along? I feel like, I assume you're not being mean because I've got myself distracted on a side quest, which I said I wasn't going to do. It's great, mate. Like, probably not even going to run it this stream. Okay, so we cannot allocate, right? So everything has to be stack allocated or some abstraction that doesn't allocate. Could you define your own allocator that just allocates to a fixed block? Yes, you could. What a great point. I could, okay, create my custom allocator, which just uses some sort of stack allocated space, okay? Absolutely correct. There is another issue with stack trace that is fine for the 99% of the times you want to use it, but is not okay for here. And allow me to elucidate. Okay. This code does have to be fast. It has to be perform. Obviously, there is overhead in this and there's overhead in this, but the danger zone, right, has to not allocate, has to not grab any possible mutex or lock or anything. It also has to be pretty quick because you're jamming this thread off to profile it and then resuming it, and you don't want the game to, like this, if it's stuttering, then you won't be able to play the game normally and you won't be able to get a representative stack trace, right? So you won't be able to get a representative profile. Std stack trace resolves symbols as part of its implementation. It will grab the stack trace for you, and then it will go through, and then it will walk all the debug information, do all the string, whatever it does under the hood, to give you like the function names, right? And you cannot defer that. We need to defer that. We want to just get some array of void pointers, which represent the call stack. And then, because we'll be running a separate thread, once all the threads are resumed and on their merry way, we can then take our time to do the symbol resolution, which is slow, okay? So yes, we will use debug help, but we can't use it here. We want to just as quickly and efficiently as possible grab a collection of void pointers, right? And then do the slow symbol resolution later. Does that make sense? That's why you can't. It doesn't really matter, right? Say you could even defer to stack trace. It's irrelevant because it's still going to be done from the calling thread, not from the current thread. So I originally thought when I was thinking about this, because I was thinking about this, I've been thinking about this for a lot, right? And I was like, this is going to be fun. Wouldn't stack trace be much worse than a release build? I don't know, because I'm probably going to do release with debug symbols anyway, or at least for when I'm profiling anything. Okay, so Windows has stack-walk 64 from Big Help, right? Notice here, I give it a process and a thread. It's kind of hard to know for sure, but I'm given to understand, kind of reading around a few bits and places and seeing how like Google and stuff, like Chrome and stuff have done this. This is a very heavy function. I believe it allocates internally. This is for remote debuggers. This is to say for that process over there, right? And that thread, give me the stack trace, because you can remote suspend a thread or whatever, it doesn't matter. So well, it won't be throwing because throwing potentially has an allocation, right? So this is how, if you were to first come across it, right, this problem, you would probably end up at this. And when so I've done this before, right, this kind of sampling profile built embedded into a game, and I used stack-walk 64 and I never once deadlocked. However, I'm always keen to learn new things. I'm always keen to try out something new. Then I found this, and it's so refreshing to find an actual technical article, right? Like, so I'm going to put this in here because this is a absolutely fascinating read for all sorts of Windows internals curios. And he basically, at the bottom, like solves my problem by using RTL lookup function entry. Okay. Which says, given an instruction pointer and an image base, right? And somewhere to put and a function table, which I think you just fill, it just populates with the unwind history. Given an instruction pointer, tell me who called it, given this, everything you know about this, right? Which is cool. Okay. So you can get, and then you, sorry. Given an instruction pointer, tell me the function that this is in. Okay. So it'll pass the PE files, it'll do all that governance for you, and it'll say, it's this function that this RIP is in. And then you can do virtual unwind, and you can manually unwind that stack by one and find out the caller of it, given various other bits of context, like the stack and the instruction pointer. And you basically just do this in a loop, and you basically say, you pause it, you grab the context of so he does it for his current threads, right? You can see here he uses RTL capture context, but we can do get thread context, or whatever the Windows equivalent is, to say, in the suspended thread, please tell me what the instruction pointer is. And then we can say, hey, given this instruction pointer, which is literally the instruction the thread was executing when you suspended it, what function is that in? Okay, I'll unwind it by one. And then you go back around again. Oh, this new one, what's that in? And you keep going up, and then you basically just fill out an array, and bish bash bosh, done. Thoughts, feelings? Like, the code's basically written. There's this absolute horror as well, which is absolutely fascinating. We'll get to that in a minute. So as long as we do that, yeah, like, I'm just surprised Windows doesn't do it for you. Okay. I want to use, right, so, whoa. I mean, I have no idea how Sentry does its own handling. It probably just grabs the, it might do, like, I think Chrome crash handler does something like this. Get it wrong. Yeah, we'll see what happens, right? So we probably want something like auto call stack equals third array void pointer. Yeah, it will. No, because you don't send that context. Well, I'm pretty sure when you do get thread context, you get a local copy of those variables, right? you'd have to use set context to write them back. So we're just going to manipulate our own local version of the stack pointer to effectively manually pop a frame pointer in a very specific circumstance. We're never going to write that back. Now, this feels like a thing that we could do. Okay. The problem here is that we don't know how big the call stack's going to be. Okay. And we can't dynamically allocate. So we have to assume some upper bound, right? The question is, like, if I just return this array, which I'm more than welcome to do, how do I know where it ends? Like, you probably could assume that the null pointers, right? If you fill this with zeros, which this will be zero initialized, is. However, I think this is an excellent place for a new C++26 goodie. What is that doing there? Called in-place vector. All right. Now, what this does... Oh, does it not like it? Interesting. We'll see if this builds. No, ClangD will not like this. What this does is if you took std vector, right, and you took std array and you smash them together at high speed, this is what would fall out. This is a array. It is a array where you can push and pop back to, right? But it is stack allocated with an upper limit. So we can do call stack dot push back. I don't know, whatever. Do null pointer, for example. Okay. So this will then allow us, and then if we return this, this will internally know the size, right? I mean, it's got size, right? It knows how many you push back and pop back. It knows how many in it up into that upper limit. So we would just have to do std in place vector voice. I don't know why it doesn't like. I don't know why it doesn't like this void star. There might be some restriction. I've never used this before, by the way. This is literally the first time using it. But that's I think that's kind of fun, right? And then I'm hoping, because the only disadvantage of this is that it will have to copy this much space out. So returning from this will invoke quite a large copy. But I'm hoping, if we're clever and careful, we will get an RVO, because we won't have multiple returns. We won't have any deducing types for the return types. We won't have any implicit casts. So we should get an RVO, at least on the release build. Hello. Thoughts? Feelings? We happy? I can hear Haran's veins popping out his head at the thought of doing all this. Right, let's give this a go. Right, let's just see what happens. I don't know how I'm going to test it. I don't know how we're going to run with it. I think I will keep this like comment in here though, just as like a friendly reminder to be careful. Okay, so let's start off with what he's got. Okay, so we're gonna do auto context equals context, right? So that's a stack allocation. That's absolutely fine. And then we're going to do, try and work out what we're going to do in case of errors. We probably will want to throw, but we can't throw from within the danger zone. So we do need to be a little bit careful with that. It is indulgent. All of this is indulgent. allocate before suspend. I mean, it's just a stack allocation, right? Like, there is no allocation here because the frame, the function epilogue prologue will just adjust the stack pointer for us. In fact, one absolutely fascinating thing I found out from this article, which I didn't realize before, is functions must adhere to strict requirements for the prologue, epilogue, and everything in between. For example, you're not allowed to push to the stack in the middle of a function in Win32. So, like, this ain't gonna be doing nothing. Okay. Right. So we're going to get the context. Then we're going to do... I need to do error handling without exceptions, which I'm notoriously quite bad at. I guess it's either go to or do while false. And then I suppose we will put that right at the beginning anyway. So put that there. Put it there. Let me just... Yes, I might not fill it. Like, there's no guarantee that my stack trace is going to have 100 elements in it. I need to track how many I've put into it. I could use a sentinel value. I could just assume the null pointers are. I could return a cursor. But why not use like this new thing that is basically designed to solve this exact problem? Failed to get stack trace. So I like to assume failure and then seek success. So if we get to the bottom over here, then success will be true. Otherwise, something has gone wrong. Okay. So thread context. Win32 get thread context. I should actually probably check these as well, but I'll try to do it in a minute. Get thread context. Returns, if the function succeeds, the return value is not 0. All right, so we're going to do if get thread context of handle context equals, if that equals 0, then we will do success equals false, right? Oh, sorry. I might have to do it the other way around. I might have to assume it's true. I don't really like doing that, but otherwise I haven't really got anything. Sorry, no, sorry, what am I doing? Break. Right, there you go. Okay, so this is, if you've never seen this, this is the do while false paradigm. It's basically go to with extra steps. We could just use go to. I'm really not that fussed about it, but it's kind of interesting to see. So we're going to do all of our checks, and if at any point we don't like anything, we'll break out, which means we'll never execute the last line, which means we will always resume the thread. We'll never do any dynamic allocations, and we'll throw ensure. Have I not got? It's about the closest I will get to programming in a C-style fashion. Whether you like it or not. I'm sorry. Okay, so we'll get the thread context, and then back to the article, we will then do... I'll need a auto table equals... I think you just need to shove this somewhere. I don't think it really is. I don't know if you actually use it. Yeah, this is not my usual style of programming. So while context dot rip doesn't equal 0. So whilst we still have an instruction pointer, and context dot rs dot RSP doesn't equal 0. Oh, I got data loop. This has the ability to skip stack frames, but I'm probably going to maybe do that in post-processing. I haven't really decided yet whether I want to do that. I'm going to keep the code simple for now. So I don't need to do frame counting gubbins or precursor because I'm absolutely because I've got in-place vector. So let's do auto image base equals, and I'm going to stick very carefully to the Win32 types here. Normally, so the fixed width integer types like studio Win32t, etc., I tend to use those. Those are vocabulary types. Those are the interfaces. Those are the things people should be communicating with. But internally, especially when doing weird Windows stuff, we should definitely use the very specific types that they have, even if we know that they're an alias or something. Like, we should be specific when talking to these APIs. And then we're going to do const auto func equals RTL lookup function entry, right? And this is then going to have context.rip and write out the image base. So that is the image base that the function is in, and table, right? I think it just populates those. Okay. I'm going to do if. So here's right. So then we're going to get into the interesting bit, right? So this will resolve the first function, right? And then obviously we need to do the unwind. So the unwind says, I probably need to put the first function in the frame, actually. I just didn't realize that. Hang on, before we do that, let's do D64, mate. It's just it's a quad word, but half it and double it again. There's a few things to pay attention to here, which are where's the in-place vector? Should not lookups happen after aggregation? What kind of lookups? Because yes, I think I agree with you. Right, in-place vector, 0.6. This is a fun example of design by committee, I think, because we now have pushback, try pushback, unchecked pushback, and we have in place back, try in place back, unchecked in place back. This is one of those things where memory safety is a big issue, hot topic at the moment, especially in C++. So new things should probably be memory safe by default, but also like backwards compatibility and people's knowledge and stuff like that. So I believe pushback now in this one will throw an exception if you try and push back to an in-place vector and there's not enough space, it will throw, right? And then you can try to do it and it'll tell you if not, or if you really know what you're doing, you can just be like, mate, just this unchecked pushback is the equivalent of stood vector pushback, and this pushback is the equivalent of I guess kind of like at, but obviously it's putting it in, yeah, it's a checked one. So we probably want try pushback and then just bail out if we're full, right? And I'm going to consider an error if we fill up all 100, because it means that we should be putting more in, right? So we can do, actually what we could do is we could be, so after we've gotten the current thread context, we need to do call stack dot try pushback context dot RIP. If not, then break, right? Exactly, yeah. Unchecked is because it's extra typing and it's unlike everything else. That's the one where you're like, oh, I know what I'm doing. The philosophy is you should reach for the safe one first, which is push back and pop back, right? And then if you know what you're doing or you've profiled it and you know that whatever, do you know what I mean? Like it's not restricting you from removing that safety net, but it's making you think about it. So I'm pretty sure try pushback. Oh, does it return an iterator? Oh, it returns a pointer. Oh, I thought it returned a Boolean. Returns the address of the thing you've pushed back. That's kind of nice. Yeah, well, let's keep going. Okay, so now we've got the first function, right? That's the one we're calling. That we probably could skip that because it's technically going to be. Oh no, wait a minute, no, because we're going to be calling it another thread. Anyway, that's fine. Let's keep going. Yeah, stood address of is only a real thing because you're allowed to overload the address of operator, and you still need a way of like bypassing someone else's bullshit. Remove. Oh yes, thank you. Good spot. It's technically the address of operator, which I do, right? And you shouldn't do, but I do here. This allows me to pass in this thing into like C functions and have it automatically fill in the inner object. It's probably not needed. Okay. There's so many symbols. Right, okay, fine. So we've got this. So now we have an interesting thing, right? Because this is allowed to fail. Okay, let me just see if I can find the Microsoft documentation for this. Such as the active function tables so this is all the information that it needs to do unwinding, right? So Microsoft maintains function tables that corresponds to the specific PC value, blah, 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 blah. If there's no entry in the function, it's null, otherwise the function. So you might think that returning null is an error. If it returns null, you can, at least as far as I can aware from this article, you assume that it is a leaf node, right? So that means it is a function which does not call another function, does not allocate any stack space. And in those two, if those two conditions are met, maybe some others as well, the compiler is basically allowed to say, I don't have to emit, Windows will not emit a function table for that, right? So what you have to then do is, and you can see what he does here, is you manually pop, but you know that the stack point, the top of the stack pointer is going to be the return address because it had to have been pushed before it invoked that function, right? And it's not done any stack allocation, right? Because otherwise it wouldn't be in here. So, and this is like an optimization that it can do under the hood, right? Because then you can elide the function epilogue and function prologue, right? And just pop RSP at the end. What he does is, and this is quite clever, is he takes the context that you've captured from the frame and it says, right, take the thing at the top that the RSP is pointing to, right, and stick that into RIP and then update RSP to advance it, right? So you're going to manually simulate a ret instruction and then continue back round and then try and say, all right, well, what function does this fucking point to? Yeah. And then the happy path is it gets you the function and then you can do the unwinding stuff. So you either say, hey, Windows, can you unwind this for me? Or Windows is like, no, you have to unwind it yourself. That is my interpretation of this blog post anyway. And like, if it works for him, all right, so if the null pointer, so let's do this one. So we're going to do context dot RIP equals, what is this type? Are these void pointers? They are themselves dword 64s. I think it's really grim. I think you have to convert that to an actual address in the program and then dereference it. So I think we're going to do auto rip pointer equals reinterpret cast dword 64 context dot rip. So we're going to take that value in there and turn it into a pointer, and then we can do context dot rip equals star rip pointer. I guess it could be const. Right, and then do context dot, because these are not pointers themselves. I think this might be a type error here later. I don't know if it's going to automatically convert that to a void pointer. I highly doubt it. So I suspect that'll be a compiler error later. plus equals size of context.rsp. Oh, you're so right. You're so right. Thank you. What a great spot. Take the number that represents the address that the stack pointer of that thread that's currently suspended is pointing to, dereference it to grab the thing that it will return to when that function that we've suspended will return. If we've suspended in a leaf node, shove it in RIP. Just give it another jolly good go. Simples. It's probably not the worst pointer code I've ever written. It's up there. Okay, so now we're on the happy path. So auto handler data equals voids. Nope, can't do that in a moment. Void start. And then auto estab. I don't know why I need an establisher frame. I'm sure it makes sense in a minute when I look at the actual function. dword64. And then we're going to do, right, RTL virtual. Let's see what Windows has to say about this. Retrieves the invocation context of the function that precedes the specified function context. Done. This function is not implemented on all process platforms, and the implementation is different. Each platform supports it. Sure, fine. Like, we only care about x86. I'm sure it's fine. What's going to return? The function returns a pointer to the section. It doesn't even say it fails, which is like the complete list of. I think it goes through and figures all this out. Like, I'm not writing any of this, like passing any of this code. It doesn't say it can fail, but I think I probably should assume that it could return a null pointer, right? Right, hang on. Right, so handler type is I want an unwoo flag handler. Okay. And then image base. And then now I've got the context RIP, which I may have to have advanced or whatever. Func, sure. Rewrite data to the context, because I guess it updates the context. I think it updates the context, and then when you loop back round, right, you'll do RTL lookup entry again. And then you'll resolve it. I guess it can't fail, but like these, I don't think we actually care about these. I think these are just like there just to satisfy the API. I mean, it's not that much just to break here if needed. Oh, it's unhandler. What have I done wrong? That wants to be passing the no constant's fine. Oh, that break's not going to work for me anyway because I'm inside a loop anyway. So yeah, screw it. Let's just assume it. Let's just assume. I guess the next function would fail anyway. That's fine. I suspect actually what it does is it sets this to, when it can't get any further, it sets the RIP to null, to 0, because that's what it checks on the way out. So I think that's fine. Get rid of that. That's it. I think that's how you do it. Bish bash bosh. Probably have to run this. It's fine. It's fine. Hello, I am okay. Thank you very much for asking. How are you? I can't wait on a stop token, can I? I didn't write these macros, so they don't count. They don't count. They do not count. I guess what we could do is something like so this is just I want some multi-nested calling, right? So this is going to create a thread which runs lambda, which then executes a meaning invoke lambda, which then executes a meaning invoke lambda, which then executes a meaning invoke lambda, which is then going to wait for the stop token. Okay, so I'm hoping I'm going to have to. I really hate using timing code in threads, but I'm going to have to kind of like. Actually, hang on. I probably could. Hang on. Auto ready equals stood atomic bool false. And then I could probably pass that down and be like ready equals true. And then do something like ready dot wait for this to be true. Or have I got to put, which way is it? I don't want to sample it until I know I'm at least in here, right? The value to check the attempt project no longer contains. So check it no longer contains false. No, I've never implemented agentic assistance. I wouldn't even know what that means. Okay, right. Now that we have this misery, which has made even my eyes bleed a little bit, so her hand is definitely twitching at the sight of all this. Let's do const auto stack trace equals thread dot stack trace, and let's do first of all assert true, not oh, you know what's not onto ranges, so let's do ranges. Check is 90, right? This will not compile. Yeah, all this miserable casting. Is this just a header? I might pull this out for CP file, to be honest, because then all the Windows header shifts out as well. I might do that later, because I can't remember why I made it. I guess at least the constructor has to be templated, but then I suppose the static helper will have to be templated. Oh yeah, at this point, like, fuck it, might as well keep everything templated. I went through that whole thought process in my head then in about 3 seconds. So I'm going to need to do some casting. Do some casting. It's going to be reinterpret cast, isn't it? And then where I do the other one? Where do I do the... Is that the only one? That's the only one I do, isn't it? I'm trying to. Reinterpret. Come now, Pep. Can we spell it? The insolence. It's gonna work, mate. You're gonna get a sweet stack trace. I mean, it's it's definitely frozen. Is that my dodgy test code? Question mark. Oh. Who's in the issue? Well, at some point, I'm probably going to want to do thread dot like request stop. That does mean though that test passed. I think it's just normal C++, mate. Just normal C++. God damn it! I was so confident. So confident. Let's see what's going on. Right, let's pause this. So all this pausing and inspecting threads, like, this is what VS Code is basically doing probably under the hood somewhere along the line, or Winbag or GDB or whatever it is. Okay, where's the main thread? So this is test suite run, test body, thread call stack. This is not C++ you would normally write, by the way. I'm doing some quite low level, quite weird stuff. Do not let this intimidate you. And I really hope that this is not putting people off learning the language, because I'm using all the advanced features and doing some quite gnarly stuff with it. Okay, so what's this thread doing then when it's at home? That's thread start. Wait, that's an internal thread. This internal thread gubbins. Here we go. Right, so this is and it's here. So it is currently executing. It's stuck in this loop, right? And this is... Why is that? Have I taken a copy of that bool somewhere? Only if I want to use a non-sequentially consistent memory order, right? The standard operators by default will use dot load or whatever, but with memory order sequential memory order consistency. Whereas I just it's not that. I can't work out, like, I passed the reference all the way through, and I'm not worrying about the decay stuff from the thread, because this is a capture for the lambda. Ready is true as well in the locals. I'm not really sure I understand. I could just sleep, right? It's just lame. You need to notify. Oh, is it notify what? You're so right. So right. It's not just enough to do it. tell someone it's done. Of course. We all make mistakes. Okay, that failed, which is... Ooh, through an exception. I failed on thread bot 155, so that has to be the... Why? Interesting in why we... Right, let's debug this. Let's debug this, because no point... There's literally no point guessing. Notify 1 is not in the loop, no. The loop starts afterwards. Right, what are the shortcuts for this? FNF10, sure, whatever. Right, get a call stack, get a success. Right, suspend thread. So the thread should now be suspended. Get context. Well, so we got the context, right? So if we explore the context, we have... Ooh, oh no, I don't care about that. Oh, how interesting. Have I got to... I bet I don't have the right thread permissions. Oh, no. I need, like... Have I got to open the thread again to get more permissions? Or do I do that in create thread permission all? Hang on. Give me a second while I rage at the world. Right. I don't care about... I want, like... Some access rights, including thread set token and thread get contents, may not be present. Lead time expected failure. So create a thread while impersonating. That's fine. But I need this, right? So, is there anything else in here about this? The newly created thread has full access rights to itself when calling the get current thread function. But I'm not that thread. I'm another thread. Here we go. The new handle is created with the thread all access right. If a security script is not provided when the thread is created, default script. When a caller attempts to access the thread with the open thread function, the effective token call is valid against the security script. So I think I have to open the thread with access all. The identifier of the thread to be open. That's the thread ID. Right. Oh, Jesus Christ. How do I get the thread ID from that, from open thread? Because it's not the handle, it's the thread ID, which is different. Yes. It should already have all perms. Yeah, but then why am I not getting any of the stuff? But does it only have all perms from the current contact, from the current thread? Do other... Because bear in mind, I'm calling this from a different thread. Well, let me just try this, right? Let me just try this, because this might be auto h equals open thread thread. Is it not a thread access all? Thread all access. Thread all access. False. Get thread ID handle. I don't... You're right, I just said I don't need that. Okay, so it's still not liking that. Let's just run this under here. Step in. F10, suspend thread, open thread. H got me a new handle, so I should have all the access. Get the context, get thread context. So context should be. Go away, watch. Don't need you. Right. I feel like I'm missing. There's something else. There's definitely something else. I remember I remember doing this before. Didn't I do this? Hang on. Whoa. Stop. I might even have some code from this in the previous project. Here we go. I need process query information when I open the process. Oh, did I set that? Oh, what great. Yes. Isn't there something else you have to do as well? Yes, you're right. There's some other gubbins you have to do. Where's that? Debugger registers. Yes. Then you have to do context flags equals context full. I might not need to do the handle trick then. Let's just see. Play Windows. Okay, let's have a look at that. What am I doing wrong now? So got the H, set the context full. Why am I still not getting any of the registers? Okay, fine. Let's be more specific. Let's do thread get context. I suppose I should only be asking for what I actually need. There we go. Right, so I do need to use that handle, I assume. Which means I need to technically need to auto-release that at the end, don't I? So I'm in the danger zone, so can't use auto-release. So, I'm gonna have to do it the miserable way. If H equals null break. This is why I absolutely hate about this doing this kind of programming. It's the manual resource cleanup. If H, hang on 1 minute. If H doesn't equal null, close handle H. Could I? Yes, you're right. I could just do. Yeah. Okay. Fine. Let's do auto thread handle equals auto release handle, null, null, auto h, close, handle h. And then we can do thread handle equals that, and then if not thread handle, then we will continue, and then in here goes thread handle, and now I don't have to worry about the stupid cleanup. Right. I'm so hot. No, it's outside the loop, so it'll clean at the end of the scope, which is all we need anyway, right? Because note the actual looping bit is here. This is just the do waffle, so I could just write with go-tos. It doesn't really make any difference. Okay, I think it's looking pretty good, right? I haven't actually looked at the values yet, but like we then need to resolve them. That'll probably be a utility function, I guess, given a span of void pointers. Turn it into a vector of string names. Aren't I shadowing the outer thread? No, because the outer thread handle will be just handle underscore. And even if it was called thread handle, it would be called thread handle underscore. So I think that's fine. Declare on 108. Oh, sorry. I see what you mean. Yes, there you go. Sorry. I don't have. I really need to get a reset. I don't think I have a Oh, I do have a reset. Oh, yes, I do. There we go. Right, let's just check that still works. Okay, I suppose we can have a quick just look at the values, just see if they look stack-esque. Step over. So our stack trace now is, oh, I bet it doesn't have pretty printers for this new type. Great. Oh, there you go. Brilliant. Absolutely grand. Good job. Got one. Why are the rest all null pointer? It should be at least the size should be at least 1, 2, 3, 4. Let's see if we can get that test to run. So assert greater or equal to like 4. The due, right? Because it should be somewhere in here. So it'd be 1 call frame, 2 call frame, 3 call frame, 4 call frame, then also all the other gubbins that goes alongside it. Let's step through it again, see what it's doing. It should. It won't remove them. Oh, unless it's optimized it down. It's an unoptimized build. That is a good point. We could have a side effect in all of them, so it shouldn't. I don't know if it will optimize Lambda out like that, though. All right, so we've suspended it. Got that. Got the context. So now we should see in context actual values, which is good. So RIP is this thing. So we push the first one back. We do that whilst that get the image base, get the function. It's not, so that's fine. So we do that, and then we do this. So context is now, so RSP has been updated. RIP has been updated, so it should look up that function. Oh, hang on. This is not in the loop, is it? Yes. We all make mistakes. This is going to be the fun failing now of the do or false, in that I can't break out of a double loop. Could use go-tos. Could just use go-tos. Do I even want that there? I do. I always want that first one, don't I? And then after I've resolved, I'm trying to think where it needs to be based on the logic, right? So we push the first one in, and then we look up the function entry, but we don't want to do anything until we get back round again and updated the RIP. So I think you actually want it there, right? And then not here. Yes, I know. I've got to fix that next. I just like go to how you do error handling and see, right? Like I don't know what the alternative is other than like miserable nested if else. And like this is basically just like it's CS code. See what it looks like. Cannot jump. Why not? It's true, you don't need that. Is it? Is there like some sort of Windows miserable thing? Crosses initial. Oh, interesting. You can tell I very rarely do this kind of code. Let's hoist this up then. Oh, do you need to do that per thing? This might not work for me. I might have to do it the hard way. Oh, if you got to have all the variables at the top, that is absolutely gross. Absolutely hate that. That's miserable to see that. All do our force is doing is just doing that under the hood, right? Maybe we should go big, be brave. Not let society tell us what language constructs we can and cannot use. There we go. Look at that. Oh, look at that. VS Code's clever enough to resolve them to actual functions, but that's right, isn't it? Look. We go into our thread implementation, we go through the apply, we go through all the implementations of that, we go into the call operator, we go to the invoke, we then go through our first lambda, second lambda, third lambda, fourth lambda, and then we're actually in on the stop requested things. It's pretty cool, right? So we just got to write the code to do that, And we're done. The purist in me says this is absolutely fine, because this is, if I was writing this in C, this is exactly how I would do error handling, because without exceptions, like what are your alternatives other than like miserable if else statements, right? But in C++, I don't know. I'm not sure how I feel. I'm conflicted. But like, I'll leave it for now. I'll wait for someone to tell me I'm wrong. Returning from me. Oh, I see what you mean. So just return. Yes, that is the alternative. I wonder if that is the more modern C++ way of doing it, because that won't. Yeah, I reckon that's better. So let's do const auto success equals. Well, at least I got to write it if I was writing C, so I guess that's fun. This thread handle. I can put these back to where they need to be now as well, which is nice. So this can go here, and then this can go here. I think. Here. And then we can just, that should be, yeah, that's fine. Yeah, okay, cool. So that should work as well. That is better. Thank you. Sorry. Should have thought that earlier. I'll find an excuse. Call stack is not captured. Correct, Mundo. It is not. Okay, let's just treat ourselves. Nice. Okay. I think I'm going to save the resolution for next time, just because I'm going to expire in a minute. So that's, like, I hope if anyone's got any questions. Like that was a lot of low-level Windows internals and a lot of modern and weird C++ in like 3 hours. So if you have any questions, like shout them out or hang around on Discord for a bit afterwards. But yeah, hopefully that was kind of. I feel like I'm like shiny. Hopefully that was fun. Add stack trace to thread. 2 commits. Absolutely crushed it today. So a couple of things where everyone disappears off and has a better time. Super chat. Thank you so much. How very kind. I'm glad you like it. Before everyone disappears, a couple of things. Next stream. Wednesday. We'll do the symbol resolution, and then we'll start adding out the stuff to actually capture the data that we care about. So that will be sticking into some sort of container where we can log basically how often we get the same stack trace, and then do some metrics on that. I'm not sure how. I'm probably going to do the mechanics of it, and then wire a little bit of it into MGUI, and then kind of call it there. Because we don't really need to do too much. Like, there's no point doing loads and loads of profiling now until we've got the physics in and we're doing release builds. But like, I think it's kind of fun to get it out of the way now. It's like it'll be waiting for us. So I think we'll do that. Then I want to do some OpenGL profiling with the timer stuff, and then that'll probably be the end of the side quest. And then we can actually go on to do the physics stuff. So we've still probably got 2 or 3 more streams of this. But yeah, we'll do simple resolution next time and start wiring it up. new video like soon. I'm editing it at the moment. I'm about a third of the way through, so I'm hoping new video next week. If you are a member, then you get early access. If not, then you will get it eventually anyway. And then before everyone disappears off, this is see if there's anyone doing C++. Anyone doing C++? Let's see if there's anyone wants to go and raid someone whilst I go and collapse. Cannot see anyone. Give me a second. Hold on one moment, caller. Okay. Never mind. Not today. We'll do another day. I'm kind of focusing more on bug fixing videos at the moment because I find they're kind of make a good story and they kind of are helpful to other people, and it's kind of just where my mind's at the moment. I'm kind of taking just the deep diving stuff is interesting. It's just like, unless I've got a goal, it's much harder to kind of string out a story from it. But yeah, maybe, who knows. I'm always interested in doing more collabs as well, so if anyone knows anyone, then hit me up and I'll talk to anyone. Right, thank you very much for spending your evening with me. I truly do appreciate it, and I'll see you all anon.